Algebra 2, 3-3 extension, the mixture problems. We'll be doing these as warm-ups in class on the day of the 3-3 lesson. So this really isn't a lesson apart, but this will be covered on the quiz. And I have 3 examples here that we're going to go through right now. It would probably be a good strategy to watch the first one and then pause the video to kind of attempt the second one and then watch the second one and then do the same thing for the third one if you're doing it the video method. Again, if you're in class, then we'll be doing these in class together. Probably, I'm not sure yet, but probably 2 on one day and maybe 1 on the next day. These will be on the quiz and or the test. So reading this real quick, it says, suppose you want 50 gallons of a mixture that is 15% saline. If you have a container of 12% saline and a container of 22% saline, how much of each solution do you need to make the 50 gallons of 15% solution? You see, because just think about this, if you poured equal parts, if you just poured 25 gallons of one and 25 gallons of the other, you're going to get the average of 12% and 22%, which would be 17%. So obviously you're going to need to pour more of one than the other to get the 15%. This is a system problem, okay? So let's just call the two solutions A and B. Let's call the 15% solution A and the 12, excuse me, not 15. The 15 is what we want. Let's call the 12% solution A and the 22% solution B, okay? Now, first of all, that's the A and B. Those are amounts, right? So how many gallons of A are you going to pour in and how many gallons of B so that you get 50 gallons? So the first of the 2 equations is really easy. We know we want those to add up to 50. Okay, we do need to come up with 2 equations so that we can solve a system. The first one's easy because there's 2 solutions. The variables are in gallons and they need to add up to 50. We want a 15% saline solution and we want 50 gallons of it. Okay, now the second part is also fairly simple until the end, because you want 12% of A and 22% of B. If you would just change the decimals, change the percentages to decimals, you'd have 0.12 of A plus 0.22 of B, and that's got to be equal to, and what a lot of people will say here is 0.15. That's actually not correct. Not 0.15. You want 15% of 50 gallons. So this is kind of the part you want to kind of latch onto and remember the most, is it's 0.15 of 50. You see, you're taking 12% of A plus 22% of B, and you want it to be equal to 15% of the 50 gallons that we have here. Okay, so here together, these would be your system. Now, we've talked in class already about the fact that when your equations plural are in standard form, a lot of times those are kind of tailor-made for elimination, and I'm not against you if you want to use elimination here. You could multiply through by negative 0.12 or negative 0.22. Either way, the first way would have you eliminating the variable A, the second way would have you eliminating the variable B, and you'll get the same answer that I'm going to get here. Instead of doing that, though, I'm going to go ahead and use substitution, because with one simple step here, I could subtract, let's just say A from the first equation, and then we can substitute into the second equation for B. So what I'm saying is this equation, this first one, could also be written as B is equal to 50 minus A, okay? So this, just to be clear, again, this equation and this one are equivalent. And now I'm going to take 50 minus A and plug that in for B. So you'll have 0.12 A plus 0.22 times the quantity 50 minus A. Don't forget the parentheses. You must have those. And then if you would multiply 50 times 0.15, it's 7.5. Okay, and then just solving, distributing the 0.22. Yes, I'm using a calculator. You wouldn't want to make a mistake. That's 11. I should have known that. Minus 0.22a is equal to 7.5. We can combine like terms, and at the same step, go ahead and subtract 11 from both sides. So 0.12 minus 0.22 would be negative 0.1a. Careful with your notation. That's negative 0.1 as a negative 1/10. A. And then if I subtract 11 from both sides, 7.5 subtracting 11 is negative 3.5. And then what a lot of people would say here is to divide by negative 0.1, and you absolutely can do that. Negative 3.5 divided by negative 0.1. The equivalent of dividing by negative 0.1 is multiplying by negative 10. Okay, so that's sometimes easier to see. And that's going to make A equal to 35. Okay, so A is equal to 35. That's 35 gallons. Real quick, you can go back to this equation now, or maybe you just really logically understand the problem. If the total's got to be 50 and A is 35, well, then B is going to have to be 15. Okay, and again, that's in gallons. All right, so that was the first one. Again, what I suggest you do now is read the second equation or second situation and then attempt it by pausing the video. I only have 3 of these. We're a little bit limited in that, so we don't want to just spend them all by just watching me do them. Okay, so pause the video. And we'll read it, and it says the desired concentration of lemon juice in lemonade is 60% lemon and 40% simple syrup. Everybody knows that, right? Anyway, suppose you want 5 gallons of lemonade and only have access to lemonade with 70% lemon and 25% lemon. How can you create the perfect lemonade? Okay, so notice that this one, it's all about the lemon, right? It's not about the simple syrup. Simple syrup is just the other portion. So if it's 60-40 is perfect, but all we have is 70-30 and 25-75 is what that really is saying. We're going to focus on the lemon. So it's 60%, and then what we have is 70 and 25. Okay, so again, we need to write a system, and let's just use, what do we want to use? A and B works best, so let's just use A and B. A can be the 60%, excuse me, A can be the 70%, and B can be the 25%. We know that the sum of them is going to be 5 gallons, okay? Then turning the decimals, again, what we said is this one is going to be A, and this one's going to be B. Turning the percentages to decimal, you'll have 0.7A plus 0.25B, and you want it equal to 60% of the 5 gallons, 0.6 times 5, okay? And I guess just to be different, let's go ahead and do elimination this time and multiply through this top one. Let's go ahead and multiply through by 0.7. We'll eliminate the A values. Actually, let's make it at negative 0.7. Multiply this equation by negative 0.7. And what we'll get is negative 0.7A minus 0.7B is equal to negative 3.5. And this really then is the system that I'm going to use elimination. Okay, please understand again what I did to this top equation is now an equivalent equation down here that is compatible with elimination in this problem here. This here actually will also be 3, right? So as I add down, I'm going to get 0, and then 0.25b minus 0.7b would be negative 0.45b, right? And once more, here's 3, and I'm adding down, and I'm adding it to negative 3.5, so this would be negative 0.5. Negative 0.5. And negative 0.5 divided by negative 0.45 is 1.1 repetent. Okay, so that's okay. It's okay that we get an answer like that. And again, what did I do? Well, you got 0 here, so this is like non-existent. So this is really saying negative 0.45b. So I want to get b by itself, so I've divided both sides by negative 0.45. 0.45 is 45 100ths, which is 9 20ths. You could multiply by 20 over 9. That is negative 20 over 9, just to make the same point here as I did on the last problem. Anyway, that came out to, as I said, 1.1 repetent. B is 1.1 repetent. And if you know that they need to add up to 5, so that's this in gallons, they have to add up to 5, then the other one would be 3.8 repetent. And I won't get into the fact that 0.9 repetent is equal to 1 in this, but this is actually a true statement here. And you can ask me about that in class if you want an explanation. Therefore, when I add 0.1 repetent to 0.8 repetent, that actually is 1, and then you have 2, 3, 4, 5, right? There's your 5 gallons. Okay, now again, pause the video if you would, or well, actually, after we read it, you should pause the video and attempt this one before you just watch me do it. It says you want a 10-pound mixture of nuts with 20% cashews. If you have a mixture of 40% cashews, how much of a mixture of 10% cashews do you have to add to get 10 pounds of 20% cashews? Okay, so again, let's let A be the 10%, and let's let B be the 40%. And I may have done that backwards, but it really doesn't matter, right? Doesn't matter. So they want to add up to, okay, 10, I missed it there, 10 pounds. So A plus B is 10. And then 0.1A plus 0.4B is going to be equal to 0.2 of the 10 pounds. And this problem's in here just to kind of set it apart from the liquids in the last two problems. Right now we're talking about nuts. Maybe you don't like saline, maybe you don't like lemonade, maybe you don't like, or maybe you like nuts though. Okay, maybe you're allergic to nuts, but you like lemonade. There's a problem here for everybody. And that's our system. Now, just to kind of end this video quicker, you use either method that you want here. Does not matter to me. A is going to come out to 6.6 repetend, and B is going to come out to 3.3 repetend then. Okay, so approximately, if you wanted to just round it, if they didn't say round, but if we round it to the nearest tenth, it's approximately 6.7 pounds, where this is about 3.3 pounds. We are rounding there, and I do like exact solutions, but when we're talking about a real item like cashews, then maybe this is what you go with here. Okay, thanks for watching.